Hello learners, we welcome you back in Vidhai. This video is brought to you by Exams Vidhai. It is a non-profitable initiative by the students of IIITDM Kancheepuram. In this part of the video, we are going to cover scattering and its types, where we'll be studying about elastic scattering, inelastic scattering and its different types, which will include Rayleigh scattering, Mia, Raman and Tyndall scattering. So let's start. What is scattering of light? The scattering of light is the phenomena by which a beam of light is redirected in different direction on interacting with the particle present in the medium. So as the name suggests, scattering means getting scattered. So when a ray of light is made to fall on a particle, here particle is also called a scatterer. So particle is also known as scatterer. When the ray of light falls on the particle, it gets redirected in different directions, and this is what is called scattering. There are two different types of scattering. First one is elastic scattering and second one is inelastic scattering. So elastic scattering is if the energy of incident beam of light and the scattered beam of light are same, then that kind of scattering comes under elastic scattering. And if the energy of the incident beam of light and the scattered beam of light are not same, then it is called inelastic scattering. Further, scattering are classified on the basis of nature and size of scatterer. So let's start with the Rayleigh scattering. The scattering of sunlight by the atoms or molecules of the gases in the Earth atmosphere is called Rayleigh scattering. Here S, which denotes the scattering, which is proportional to 1 by lambda to the power 4. Here lambda represents the wavelength. Did you ever wondered why sky appears blue in color? This is due to the Rayleigh scattering. When sunlight passes through the atmosphere, the blue color is scattered the most since its wavelength is the smallest. And as we have read in the Rayleigh scattering, S, which is the scattering, is always proportional to 1 by lambda to the power 4. So the smaller the lambda will be, it will be scattered more. So the light having the smallest lambda will be scattered more. But you must have observed that during sunset and sunrise, there is some reddish appearance in the sky. It is because at that point of time, light has to travel the larger distance, and the light, which is red light, since it's having highest wavelength, is getting least scattered and reaches our eye. So let's come to Mie scattering. When the diameter of the scatterer is similar to or larger than the wavelength of the incident light, then this kind of scattering occurs. Mie scattering is caused by the particles which are a bit larger in size, such as pollen, dust, smoke, water droplets, and the other particles which are present in lower portion of the atmosphere. This kind of scattering is responsible for the white appearance of the cloud. Tyndall scattering. The scattering of light by the colloidal particles in the colloidal solution is called Tyndall scattering, or it is also known as Tyndall's effect. This kind of scattering you must have observed in your houses as well. So you must have seen when the light rays enter from a small hole, then the dust particle coming in that path of light became visible, and that's what the Tyndall scattering is about. Teeny dust particle present in the air of the room scatters the beam of light, then its path became visible to us, and this is known as Tyndall scattering. Raman scattering. The interaction of light rays with the particle of pure liquid or transparent solid which lead to change in wavelength or the frequency of the incident light, then this kind of scattering come into play. So this is the incident light and these are the scattered light. When the wavelength of the scattered light is greater than the wavelength of the incident light, then it is called Raman scattering. That is called Stokes-Raman scattering. When wavelength of scatterer is equal to wavelength of the incident light, which is here the lambda of laser, then it is called Rayleigh scattering. And when the lambda of scatterer is less than the lambda of incident light, then it is known as anti-Stokes-Raman scattering. Let's recall what all different kind of scattering we have read. First, Rayleigh scattering. Here, scattering takes place by the gases, molecules, atoms and molecules of the gases. Here, we have seen that scattering S was proportional to 1 by lambda to the power 4. Thus, it means that lesser the wavelength, more the scattering. Then we have read about Mie scattering. There scattering takes place by the particles which are present at the lower portion of the environment, which include pollen particle, dust particle, etc. Here diameter of the scatterer is larger or equal to the wavelength. Then coming to Tyndall scattering, here scattering takes place by the colloidal particles and the path of light of those particles, path of light becomes visible due to scattering of the particles. Then in last we have read Raman scattering. This kind of scattering takes place by the particle of pure liquid or solid, and here wavelength of the incident light changes after getting scattered from the particle.